Today we're going to do 3.4. 3.3. I take that back. 3.3. It says 3.4 on the top of it. That's a misprint. It's on the derivative of inverse functions, and I always struggle with this section because I'm going to teach it. You're going to think it's kind of easy. You're going to finish the assignment in class. Everybody always does. But then, and then if you look at it before the test, you'll get them right on the test because they're easy. But then everybody always forgets how to do it. And so some years I've done it at the end, like at the end of the sequence. Sometimes I do it now. But I think we're due for an easy one because the last couple were hard. So we're just going to do it. But it's not very important. It's not like chain rule's huge. Implicit is very large. So those are the ones we killed. This one, topic, is not something that's going to make or break you in calculus. You may never see it again, except on a test. But you won't use. We haven't used it in Calc 2 ever, Calc 3. It's okay if you forget it. On my test, it'll be at most 1 or 2 points. Same on the AP test. So I'm just saying today's. Oh, my glasses are falling. Is just not particular. Oh, you didn't grab one, pumpkin. Not particularly important, but in order to be able to cruise through it, you do need to listen. It's not something that you're intuitively going to know how to do. So today and tomorrow, I think you're going to finish in class time. So that's kind of nice because I killed you on the chain rule and implicit. I sort of apologize, but it was necessary. So I always try to redeem myself by a couple days where I won't kill you. So that's today and tomorrow. All right. So first of all, with the formative quiz on implicit, I don't want to do it just to do it. So I feel good about it. I thought that I always go look at stuff, and the stuff on implicit has looked good, but I just want to make sure this is the level that you need to be able to do. So let's all go do number 1 first. And we'll see how that goes. And it'll kind of determine the flow of the rest of it for us and B and distance learners. I'm just going to let you guys be my testers here. Go do number 1. We'll see how it goes. If it goes well, we might just peruse the other 3. The Delta Math had some that are harder. I like that. I like it when you practice harder than you have to play. Makes the tests go way better. On the last test, there wasn't anything lower than a C because all your homework was harder than the test. Which is a good thing, right, Harper? Because the homework's only like 10% of your grade. So if I made it easy, then the test was easy. There's a method to my madness, Harper. I don't know the answers, so first hour. It appears that the answer's been factored, so make sure you factor cancel and watch your signs. Those of you at home, I'm waiting for them to do number 1. It'll determine how much of this I need to go over. Today's process, you're going to do most of it in your head. That's why it's going to go fast. But you have to know what to do in your head. So, you guys should do such lovely work. I love it. Watch your signs. If you make a sign error, you're going to find your answer. That's anticipated. So while you're waiting, go double check. I'm seeing about 50-50 of two different answers, so I'm going to go through this one. I'm seeing B's, and I'm seeing D's. They must be really similar. What's the difference between B and D? Go ahead and look. What's the only difference? A sign, right? Go check your work. I don't know which one's right, but I'm assuming it's either B or D, and it's about 50-50. If you don't have B or D, I think there's something larger wrong. I don't think I saw anybody without a B or a D. So go double check your signs. Make sure that you have that negative out front with that product rule. So make sure you saw it as that or as that, but it has to be distributed in. It's either B or D. I'll walk around again. See if any of us have changed our B's and D's. I'm seeing more B's than D's, but I think I gotta do it because there's still people rock solid on their D's. So here, we're gonna do this one, all right? And then I'll talk through the other ones. So first thing you need to do is take the derivative of both sides. You'd have a 3x squared minus, either pull the 3 out of the parentheses and then distribute it back in, or leave it as part of the first function. It does not matter. So I think I'm just going to leave it out for now and do first D second plus second D first plus 6y times y prime equals 0. All right, how's that? We're good so far? Next step, I'm going to distribute this in, and they both become negative. My guess is that's where there was maybe a sign error, but I'm not sure. Am I good so far, Charlie? Next step, collect all y prime terms on the left and move all non-y prime terms over to the right. And it looks like they're leading on these two with the x squared term, so I will subtract the 3x squared and add the 3y. How am I doing so far? Is it looking like yours? Okay, then factor the y prime out. Negative 3x minus 2y equals negative 3x squared plus 3y. Whoops. Nope. 6. Sorry about that. Now I'm good, right? So then I will subtract off, or divide, I mean, by negative 3x minus 6y. Still looking good? Okay. Now on the top, I'm going to factor out a negative 3, and I'll have an x squared minus y. And on the bottom, I think I'll also factor out a negative 3, and I'll have an x plus 2y. How am I doing? Good? Gone? Gone. I'm getting B. And that's what I did see the most of. I am getting, wait, no, I'm not. What's wrong with mine?
You made a mistake. You did a minus 6y prime. It's supposed to be plus.
Oh, why didn't you tell me? Right here?
Yeah.
Oh, okay. That's going to change this. That's going to change this, right? What else is it going to change? This, right? Am I changing everything right? So it's going to change this. Guys, what happened? Why do I have an x squared minus y on the top? What was that?
I kept getting x squared minus y.
Anyone else? There's a typo then. Huh?
I just factored out a 3 and not the negative.
Yeah.
And then you get negative x squared plus y, which is
Y minus x squared.
2y minus x.
That's what I was thinking.
Oh! Yes, tricky, 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 right? That is tricky. It could be the opposite of the top over the opposite of the bottom. And then it's A, and we all missed it, even me. I'm glad I did that one. You go, girlfriend. Love it. Yes. I was going to say this can't be really a typo because this source is rock solid. I've never had a typo. All right, so I'm not going to go through this one, but remember with the equation of the tangent line, you're just going to be finding your derivative implicitly. Remember, the derivative, the slope is always a number, so be careful you don't put your function in for it. That would be choosing A. So let's go take a look at number 4. All right. This one's easier than the one we just did because there's really no room for sign errors because there's none of that product rule in it. So that last one, if you worked through the process, this one's pretty easy. The one I want to talk about is these two, just to make sure you know the difference, okay? So when we get our dy dx as a function, and it's always a quotient because we always end up dividing at the end, right? So we always end up getting on the top, I'm just going to write this, some function of x and y, and on the bottom, some function of x and y, whatever it might be, like we just had, right? When it asks for horizontal tangent lines, what is the derivative? We've done that one a lot. What's the derivative at a horizontal tangent line? 0. And that means you set the numerator equal to 0. You ignore the denominator. So whatever it is, you would set the numerator equal to 0. We've done that before. So I think you would have done that right. But for the vertical tangent lines, remember most of these implicitly defined relationships aren't functions. They make very weird things. Okay? And for a vertical tangent line, back to algebra 2, what's the slope of a vertical line? Horizontal is 0. What's the slope of a vertical line? Undefined, or doesn't exist, correct? And for a fraction to be undefined, the denominator is 0. Does that make sense? So had you had, like, say, 3x plus y on the top, and maybe you had a 2x minus y on the bottom, you would be looking for where 2x equals y. All right, so you focus on the denominator, and it's all about slopes, so that makes sense, right? All right, we're not going to go through the rest of that. Thank you, Harper, for catching our sign issue. I appreciate it. All right, so we're going to go take some quick notes. You'll finish in class today, but if you tried to do it right now without the notes, you would have no clue what you're doing. So now you really need to focus. You can't zone out because there's not much of a process to this. I'm going to explain it first, and then you really just need to think it through. That's why the homework's going to go very quickly, and we're not doing this entire packet. All right. Every year I struggle with this section because kids find it easy and they always forget it. And I've been doing this for 8 years, and I've yet to stumble upon a way that makes it stick. The only encouraging thing about that is it's only one multiple choice question on the AP test, and it has low results nationwide. So usually about 50% of my kids get it right, which I don't think is very good. But nationally it's lower than that. So I can't make it better. You're going to forget it. Trust me. Happens every year. Half the kids just forget how to do it, but I do my best with it. So inverse functions, let's go back to algebra 2 again. Lots of algebra 2. Algebra 2 should actually be called pre-calculus, to be honest. We use most of that. Inverse functions reflect over the line y equals x, graphically, always, right? Inverse functions undo each other. So if a point AB is on one of them, then BA is on the other. If 2 3's on one, then 3 2's on the other one, right? That's from algebra 2. Let's go take a look at a really easy function to visualize. So this is the one, you're not going to be graphing these though, and you're not going to be working with them algebraically. So it's going to be a little goofy, but we're going to go take the graph of f. I'm going to put it on here in red. I call it the shout out function, but the square root function goes like that. Go ahead and graph it and write f of x by it. And we're going to write equals the square root of x. All right, there is A. Then it says to find f inverse. All right, so I'm still in algebra 2 here. I'm going to go change the color of my pen. Well, I'll keep it at black color. I'm going to say y equals the square root of x. Who remembers from Algebra 2 how you find an inverse? Do you remember, Kalia? What do you do with the x and the y? Do you remember, Harper? Algebra 2. What'd you say?
You just switch.
You do. They switch because they reflect over the line y equals x, so they swap out, correct? So we're going to say x equals the square root of y. Now, you would have known the inverse function. If I said, what undoes the square root? What would you say? What undoes a square root? Squaring, right, guys? But this is how you physically find it algebraically and how you did it in Algebra 2. You'd swap it out, you'd solve it for y, and then you would rename y as the inverse. So this is f inverse of x. Be careful with where that -1 is because this means to do 1 over f of x right here. So make sure you embed that in there so you understand it's the inverse, not to the negative first power. Okay, so watch out for that. But x squared is the inverse. So now I'm going to go graph f inverse on here. I'm going to go change to blue. All right, come on. Hopefully, if I can get that out of the way. Do you guys see my little, there it is. Perfect. All right, so I'm going to go graph x squared. Also goes through 1, 1, but then it goes through 2, 4. Go like that. All right, those functions are f, and this is f inverse, which equals x squared. All right, got that going. Now, we know how to take the derivatives of both of those. Let's go do the blue one. This is how you write it, by the way. You do f inverses derivative, it's awkward, at x equals. All right, what's the derivative of x squared? If you can't do that, you're voted off the island, Dylan. Thank you. All right, this is twice x. The derivative of f is 1 over 2 root x. We've had that one a lot. It's x to the 1/2. You bring it out front, knock the power down. So I was able to physically find f inverse and physically take its derivative. Done. My thing that I want to show you is how the derivatives are related numerically at a specific point. So at this point, 2, 4, so just go take a look at it. I would put a, and then 4, 2. At 2, 4, I'd put 2 in right here for x, 2 in right here, and my derivative is 4. It's steep and it's uphill. So go ahead and draw that. I want you to see how the derivatives of the original function and its inverse is related. Over here at 4, 2, when I put a 4 in and a 4 in, notice what I get. I get 1 over 2 times 2. I get 1/4. What I really want you to focus on, because this is the key to the whole section, part of it is knowing how to read the notation, and part of it is really making sure you understand this relationship. So look at it. What are those? What are those called? Go ahead, tell me, guys. 4 and 1/4. What are they called? Come on. What are they called? 2/3 and 3/2. What are they called? Reciprocals. Thank you. They're reciprocals. So what conclusion can you make about these slopes? It really looks like they're reciprocals, and they are. And this is our mantra. This is actually what we're doing today. And if I said to Charlie, hey Charlie, if I started the lesson with this, I said, Charlie, if AB is on F, then BA is on F inverse. And the F inverse's derivative at B is 1 over F prime at A. So really, or if their inverse functions in G prime of X is 1 over F prime of G of X. Okay, Charlie, let's go do one. What would he be doing? He'd be going, what? Right? What this is saying is that the derivative at 2, 4 is the reciprocal of the inverse's derivative at 4, 2. That's really what it's saying. All right? So our mantra is going to be that the derivatives of inverse functions are reciprocal at their corresponding points. Okay, so flip the page. This is going to be your motto. You're going to be looking for F inverse's derivative today. All right, somewhere. They're going to tell you where. I'm going to call that A. Go like this. Maybe it's at 2, or in this case, it's at 1. Okay, -1 I mean. So you're going to be looking for the derivative of an inverse at some x value. That means you're going to go over here and you're going to say, well, I'm going to hop on the graph at A comma 2 comma something's got to be on the inverse if I'm finding the derivative there. Let that sink in. Then you're going to go to the original function and you're going to say, well, then something comma A has to be on F. This has to be on F inverse. I want you to kind of take a look. They're going to give you an x value. Let me go show you what I mean by that, because the notation, when you can't see it, we're not going to do the assignment, so we're going to go someplace else here. I'm going to go look for, here we go. See that notation right there? Just look at it. You can flip. I just want to tie in what I'm going to write on the top of that page to where there's actual numbers. We are looking for the derivative of the inverse function at an x value of 4. So you're going to go like this. 4 comma I don't know is on F inverse. And you guys are watching me like a hawk, which is good. You have to watch. There's not a lot of work to do. But remember, on our inverse functions, if this is on one of them, then this is on the other. Just like the last one. Now we're nodding. 2 4s on one, 4 2s on the other. If 0 9s on one, 9 0s on the other. Okay, so you're going to go like this. That means something comma 4 must have been on F. Does that make sense? That's what I'm saying. The next, that's all I wrote up on that other one. So first of all, you have to find your corresponding points. Your next step that you're going to do, and if you get it, you're going to cruise, is you have to figure out what the x value is on F, because that's the function you're going to be working with. On this one, we're working with explicitly knowing that it's this cubic function. So if you know what it is, you're going to have to do what I call playing with it. You have to find what number will poop out a 4. I always say start with 0. 0 poops out a 0. I'm trying to find it. 1 will poop out a 1 minus 2 plus 2. Nope. It's either going to be 0, 1, 2, or 3, or -1, negative. They're not going to make it be like 11 or 47, because you don't have a calculator to figure it out. So let's go try a 2. I'd have 8 minus 8 plus 4. Ah, a 2 for x is pooping out a 4. Does that make sense? So I'm going to say, ooh, there's my corresponding points. I think it works better with the numbers first before I go back. Is it making more sense with the numbers? All right, we'll go back for the motto, but notice what I did. I'm doing this very slowly, because once you get it, you're going to cruise. You need to get the points first. You'll always know what the x value is on the inverse, because that's always where they're locking you in. It becomes the y value on the original function. You will have to find this x somehow. You'll be able to do it though. All right? Then what you're going to do is say, well, I only have f, but I can easily find f prime of 2, and it'll be really easy to find. It'll either be on a table or on a graph, or this one you actually do have to go take a derivative, but it'll be an easy derivative, nothing crazy. 3x squared minus 4x plus 2. I'm finding the derivative on f. Okay, what will I plug in here? What am I going to plug in? Go ahead and tell me. I'm on f. What's the x value? 2. So you just go plug in a 2. Then you go 3 times 2 squared minus 4 times 2 plus 2. 6. The derivative at 2 is 6 on the original function. So what's the derivative on the inverse function there? Reciprocals. So what's, now we're nodding. What's the answer? 1/6. A lot of kids will pick this one, but don't forget, our motto today is the derivative of inverse functions are reciprocals at the corresponding points. So you're going to get on F, you're going to find a derivative. If you get 2/3, the inverse's derivative there is 3/2. All right, so we're going to go back, write our motto, and then we're going to go practice. Here's our motto. You will always be able to hop on F inverse. That's the Y value on F. Somehow you're going to have to find the X value. That's actually going to be the Y value over here, but that really doesn't matter. We plug in X values, right? You'll be able to find the derivative. You'll be able to find it easily. You'll either grab it off a table or what I call pre-measured bowls. I'll show you what I mean by that. And then this guy's derivative is the reciprocal. Now I think we just need to go practice so you can see how you work through it. Is that okay? So here we go. It says, let F and G be inverse functions. By the way, know that there's a couple ways they can tell you that, Charlie. This one actually says they're inverse functions, right? Sometimes it'll say F of G of X equals G of F of X. That means that they're inverses. Sometimes it'll say G is equal to F inverse of X. So it might actually say they're inverses. It might give you the notation for inverses or the algebra 2 when you put one into the other and the other into the other, they're the same. Okay? So let's go take a look at the type I want you to know how to do. Again, there's a lot of info in here, but we're just going to see if we've got it down, and then I'm going to let you guys go play. All right? We're going to go to, we already did that one. We're going to go to this number 1. Let's go take a look. And I'm going to talk you through a couple, and then I'm going to see how you do. Because once this clicks, it's super easy. Because there's a pattern to it. Here we go. These are called pre-measured bowls is what I call it. You don't know what F is, but they're giving you lots of information about it. They're just handing you stuff to dump in. You just have to dump the right stuff in. F and G are inverses. All right? So G is actually F inverse. Right? So I'm looking for F inverse's derivative at 1. That's what this is. The notation is what's going to get you today, Frankie. Okay? But if G is F inverse, then I'm looking for F inverse's derivative at 1. So here's how you're going to start. You're going to go 1, comma, no clue, is on G. It's on F inverse. Then you're going to go like this. Well, then something, comma, 1 had to be on F, because the X's and the Y's swap. How are we? Then you have to go find this. On the last one, I actually had to take the derivative and say what poops out a 1. On this one, I just have to go up there and take a look at what poops out a 1 on F. Be careful. What X value spits out a 1 for the Y value? Read your pre-measured bowls. What bowl am I going to, I call it that because it's like a cooking show. You just grab it and dump it in, but grab the right ingredients, okay? So what X value, Jake, goes with a Y value of 1 on F? 2. There's your corresponding points. So you see how easy that was? Like, it's not like implicit, but you got to watch. You guys, if you're at home, they're watching me like a hawk here. So I can get the derivative at 2. They gave me that bowl. See the pattern? You get the points. You get the derivative on the original function. Go ahead and tell me what it is. Pour in the right bowl. What's the derivative at 2? 3. Be careful, that's not your answer. Okay? If the derivative on the original function is 3, then on the inverse function at the corresponding points, I showed it to you with the square root function. One was 4, the other one was 1/4. So if this one's function had a derivative of 3, then the inverse must have had a derivative of 1/3. How'd that go? Do you think we need another one of those? I think what we're going to do is actually hop into where your assignment is. It starts here. By the way, this is from the year. I used to do it way later in the year. That didn't help anyway. So we're just going to put it in right where it goes. You'll be great at it today. All right. So this is actually where the homework starts. And you're going to cruise through it. But be careful. So I'm going to do this first one. What are they telling you right here? Go ahead and tell me. Ava, what does this notation mean? They're inverses. They'll either say, like on the last one, these are inverse functions, or they'll use the notation with a little -1, or it'll use this one, they undo each other kind of notation. So watch what it's asking me to find. Go here. I'm going to walk you through one of them, and then you're going to do the next 3, and then we'll turn the page. Okay? So 3, comma, something, no clue, is on G, which is actually F inverse. Write it like that. So hop on there. So this is what's happening. I'm going to use this square root thing. Okay? And it's inverse. 3 comma something is on the inverse function. Well, then something 3 is on the original. Right? Why did I put a 0 there? I don't know. So you're going to go like this. Well, then something 3 had to be on F. You're going to find that X value. This is a pre-measured bowl. You're not reading it off a table. You don't know what F is, but you know what got mapped to 3. You follow me, Harper? What's the X value? Go ahead, someone. 2. Yep, thank you. It's right here. 2, comma, 3 is on F. Well, then 3, comma, 2. There's my points. Are you following me, Harrison? I now have what I call the corresponding points on F and F inverse. This is not a major skill. If you don't get it, it's not huge. Like, you'll miss a point on the test, maybe a point on the AP test. It's not always on there. But we're doing it. All right. So here we go. The next thing I need to do is work with F, right? I'm going to find the derivative at 2. However I can do it. On this one, it's a pre-measured bowl, right? It's 7. So what is the derivative of the inverse function, right? G prime at 3, its corresponding point. What's your answer? 1, 7. They're reciprocals. It should make sense to you, Harrison, why they're reciprocals, because derivatives are slopes. Derivatives are change in y over change in x from algebra 2, right? But inverse functions swap their x's and y's. So do you see kind of why they're reciprocals just with that notation, right? So you guys go try the next one. Go to number 2. We're going to have you blurt out the answer. We'll go to number 3. We'll blurt out the answer. And you follow that little mantra. You go, I got to hop on V, which is W inverse at 9. And I would write on this and on that. So again, I'm going to have you do this on your own, but I would go like this. 9 comma something has to be on V if I'm trying to find the slope there. But V is W inverse. You're just going to walk your way through it without knowing what the graphs look like, but you're hopping on, finding the slope at one point, and then at its corresponding point, we have a reciprocal slope. Can you pop up a hand when you're done? I think I got most. All right, who's my point? What goes here? Go ahead and blurt. 4. Okay? You got to hop on, right? 4 got sent there. So I need to figure out what's the derivative at 4. Well, it's in a bowl. What's W prime at 4? -2, right? So what's the derivative or the slope of the inverse function? -1/2. Thank you for not taking the negative reciprocal. A lot of kids do that because it's perpendicular lines from algebra. How many of you had that right? -1/2. That you guys, they pretty much are all raising their hand at home. So you guys go do 3 and 4. We'll blurt. And then I promise you'd finish the assignment in class, which you will, because this is the first page of it. Go to the next 2, 3 and 4. You guys actually can just turn yours in today. You don't need to submit it on the Google form. What are we getting for number 3? Blur. 1/7. Yep, I wasn't done with mine. So just boom. Can you raise your hand if you got 1/7? They're all up again. All right, go to number 4. See what I mean, Harper? It's not hard. You get in the flow and you'll be like, this is easy. It's kind of fun. It's like a map. But what did I say happens about 2 weeks from now? You're going to forget. And then Charlie will study it for like 5 minutes before his test and he'll get them right. But we're going to have to review it again in May. It won't stay in your brain. But that's okay, Harper, because I promised you an easy day today. Can I get a blurt on number 4? Go ahead, nice and loud, guys, or I'm going to do it and waste your time.
2.
2? Amazing. All right, let's flip the page. Now, we're going to do 2 different kinds together. So we're doing most of the homework together today, those of you at home. So they're just going to turn theirs in when they're done. We're going to go take a look at this one. Just make sure you understand the notation. They are telling me to find the derivative of f inverse at 2. That's what that means. So I started the same way. It's just not pre-measured bowls this time. Right, Peyton? But they did tell me that 2 is the x value on f inverse. So the notation is what might get you today, Ellie. But the process kind of makes sense. They gave me an x value of 2 on f inverse. So something comma 2 has to be on f. But they didn't give me these pre-measured bowls that I can just find. I have to find something that gets sent to 2 so that when I put it in right here, a 2 pops out. So I'm going to let you guys find it. And I told you it's not going to be 11 or 14. It's usually like 2 or -1 or 0 or 1. It's something nice. I'm not looking at it. My back is to the board. Those of you at home, I'm not looking at it. But my guess is, and this is the first hour of the day, my guess is that it's 0, 1, 2, or -1, -2, somewhere in there. What is it? Because I see you guys already found it. It's 1. Okay. So they're telling me that an x of 1, yep, you got it. Boom, boom. So do you see how the process didn't change? You still have to find those points. You still hop on f inverse. So now I'm going to find the derivative at 1. They didn't give it to me in a bowl, Ava, but I know how to find the derivative of f, right? What's the derivative of f? You actually have to find it this time. That's not hard. What is it? Go ahead, Ava.
3x squared x squared
Plus?
plus 2.
Perfect. And I need to find the derivative. I actually have to go do some work to find it. I just can't grab it from the stem of the problem, but it's 5. Be careful that you don't say 5 is your answer, because these are always multiple choice, and what do you bet's going to be sitting there? 5. Also sitting there will be -1/5. You get why, right? What's the answer? Go ahead and tell me. 1/5. Perfect. What do you think, Jake? It's not hard, is it? It's very different from chain rule and implicit. Those are super important, super difficult. You had to do a bunch of work on them. This is the reverse. It's not very important. It's not very difficult. We're not going to do a whole lot with it. All right, we're going to go try another one. Those are all the algebraic kind. You can skip number 4 because you won't be asked that. We're going to go to a tabular one. All right? So there's 3 kinds. Pre-measured bowls, dump. Algebraic. Ava had to go find the derivative, but it was easy, right? And I saw that last one had a sine x. What's derivative is cosine. Like they won't be nasty. This one, they're handing it to you in a table. This is usually how AP tests it. Usually. They give you a table. And that's how it was tested last year, actually. So it says let f be a function such that f is equal to h inverse. So you just kind of got to think about that. F is equal to h inverse. So when it says in part A, find f prime at -1, you're looking for h inverse's derivative at -1. Let's see if you guys can figure out how you do it with it. It's the same process though. You're still going to say -1 is the x value on h inverse. So -1 is the y value on h. Just different representation this time. Guys at home, I'm just waiting for them to grab what they need off of their table. This is the working part. You always need to find it. All right, Lily, are you ready? I said this is the working part. You always need to find it. The first one we did, it was handed to you. The second one we did, Ava had to actually, I asked you guys, you got to go find it. What poops out a -1? On this one, it's on the table. What value of x spits out a -1 on h? Go ahead. What is it, guys? 0. So right here, h of 0, whoops, is -1. Well, can't put it in there. Boom. That wasn't hard, right? I need to find the derivative. That's it. The table's all about h. I need h prime's derivative at 0. I don't have to have Eva go take it. I just have to have her tell me what's the derivative at 0. 1/2. Okay? So this is equal to 1/2. So what is the derivative of h inverse at its reciprocal, at its corresponding point? 2. You guys go find f prime of 4. Notice I didn't write f prime of 4 equals. I wanted it very clear that I was on h inverse. And then you guys just need to finish the other. I think I'm going to be done. I think I'm stealing yours. But our actual assignment is the ones in my handwriting, 1 through 8. So you have about 3 more to do. So those of you at home, just to make clear what the assignment, you don't need to finish anything in the packet that we did not do. The only thing I'm going to check is those ones with my handwriting, like this, and we're currently on number 5 right here, are the 8 that are going to be considered your homework. These guys, when they're done, are going to turn it in. At home, you're going to have to submit it on the Google form. I hope they at home don't go, oh, the notes are 40 minutes long, because we did actually all the homework in the notes. It'll be fun with that.